We're part of a delegation from Vinyard and Cape Cod, looking at different wind turbines on Cape Cod, the larger ones, trying to get a feel for the permitting process that the owners of the turbines have had to go through, some of the economics of the facilities, the amount of energy they're generating, specifications of the turbines, the height, the rotor diameters, the power of them, and also to kind of hear what the reaction by the community has been. So if there's been any problems with the noise, shadow flicker, and we're hearing some things. And we're also going to see the Falmouth facility at the sewage treatment plant. That's a 1.5 megawatt machine, 15 times we're told. They're about to put up a second tower, and there's another one, the same size machine, 1.65 megawatt is the Falmouth tower. And there's another one, similar size, that's adjacent to it, that's on private property, industrial property. And then we're going to see at the Maritime facility, and that is a 660 kilowatt machine.
In the tech park, and that's the crane. He just had to have a blade adjusted. The technology park, the Falmouth Technology Park. Nope, it's owned by a private. Web Research is the facility, and they just, they own property within the tech park. Just recently put up a 55 kilowatt PV system on their roof. That's really an example of community wind in the sense that he's putting that up and selling the power to his neighbors, the excess generation. In fact, when our second turbine goes up here, there will be 3 identical machines right here.
At that point, do you end up owning the crane?
No.
It would make sense at some point.
$6,000 a day to rent it.
That's what I said. At some point, it makes sense you own it.
And it comes in on 17 trucks. So when you look at, from somebody who's looking at sort of the anti-idling policies and the carbon, and, the embodied energy of this whole project, it's horrifying.
Yeah, that sounds really interesting.
But if you have 3 or 10 or whatever, and if that's one of your major expenses, and you buy one communally, once it's here, it's here.
Right.
You don't need all those trucks.
But they, later, but in order to, you can't drive it down the road.
No, you have to have a road between each one.
But even they, it's got this massive weight counterbalance on the back of it. I think, my understanding that that's the biggest crane in New England right now.
We saw that one over on the Vinyard.
Oh, okay. Straight in front of you.
Oh, I'm still. Okay.
Where's your second one going, Megan?
The second one is going, see that sort of can thing on a post? Right in front of that.
How does this compare to the ones in Vinyl Haven as far as size?
Those are GE 1.5s, and this is a Vestas V82. Which is a 1.65 megawatt machine. It's a little bit larger.
This is a little larger than the ones they have.
Yeah.
You said where the second one's going where?
See that post that has a can on it?
Yeah.
Directly in front of that. So there's like a stand. Sorry, on the other side. Yeah.
So when you were engineering this, what was the minimum distance between them?
3 rotor diameters is the typical.
That's not very much.
But that's what the standard is in terms of making sure that the one machine doesn't steal the wind from the other. 3 rotor diameters apart is what the industry standard says, so that the machine.
Right at the base.
Between the 2 machines. So from base to base.
Yes.
Is there a ladder inside, or is
there certainly is. Yep, and it's just like the Northwind 100 that we just saw. So you put on a full body harness, and you have a fall arrestor, and up you go. I haven't done it. I'm terrified of heights, so.
Do these feather?
These blades absolutely do feather, and it's really unfortunate that that it's not running right now because of the fact that, unlike Joe's machine that we just saw, this one is so incredibly sensitive to the wind that you can sit here and watch it, and it'll just move a minuscule amount. The blades will feather, and it'll move, and it's quite amazing.
But is it doing the same thing? Is it doing it by computer timing?
Absolutely.
It's not just the wind pushing it and moving.
It has this incredible brain in there that's everything's controlled, and then there's a SCADA system that's watching it inside the wastewater treatment facility. And actually, all of these utility scale turbines are monitored by their manufacturers. So they want to see, in fact, they see more of the information than we see. So they can shut it off remotely from Portland. And that's, they can tell what's going on, and there's all kinds of alarms and that sort of thing when things are out. Yeah. It was. A lot of site work that needed to be done. Nope, this actually was pre-existing. This is one of the reasons that we thought that this would be such a great site to do this, is our wastewater treatment facility. This is a new, 2 years old. Right behind the camper is a new expansion of our treatment facility. So this spot had been up here from, it's basically when they dug out the holding ponds, and helped, filled in some of the topography here. And so we figured this is the largest industrial parcel that the municipality owns. It abuts the technology park. It abuts the highway. It seemed, and it also, we have this amazing view of the water, which means, pretty good fetch from Buzzards Bay for the wind. So we put up a Met Tower here for over a year. We had some SODAR to verify the data off of our 50-meter Met Tower, and it looked like it was a good site for us. Plus, before net metering, we needed an on-site load, and here it was. So we looked at, when we did our analysis, we looked at a 660, which is what we're going to go see over at Maritime. We looked at a 1.5 or comparable, which would be this scale, and then we looked at a 2.3 megawatt machine. But we thought that the 2.3 was just too big. So,
how's that compare in height?
You could get this on a smaller tower, but we went for the 80 meter, and we would love to have gotten a 100 meter. You get much more power.
It's a larger.
Oh, we definitely would go with a 100 meter tower, and then the blade. I'm not sure what the E90 I think is the bestest 2 megawatt machine.
Is that what you're planning for the next one?
No, we're doing the same one as this. The V82.
What was too big about the 2.3 megawatt?
It seemed like, in terms of our getting it here and also obtaining a machine, because when we started this process, as I indicated, we've been working on this for about 9 years. The wind industry, the large manufacturers, if you don't have 30 megawatts of capacity that you want to talk to them about, they won't talk to you. You want one turbine? Please. So it's very difficult to obtain a turbine, and we figured where the industry is just going for larger and larger machines, there was no way we were going to be able to get one.
Would you explain, as you did to me coming up the road, about
Sure.
moving things over the road?
Oh, so that's definitely, when you have a project on land, you have to do what they call a fatal flaws analysis to determine how are we going to get this stuff here. Whether it's the crane, I was explaining that crane over there in the tech park comes in on 17 trucks. And the tower, the base of this tower, so there are this tower has 4 sections, and the base of it is considered a super load, so it's not just a wide load. It exceeds all of the weight limitations for most roads. So when you find a manufacturer, you want to make sure that they have a really good transportation company to work with. Or your Rose Forbes, my colleague who put up the one at the base, her turbine tower left Canada around the 4th of July, didn't get here until October. So she had some issues. And part of it is permitting, and you want to make sure that you have a good person that's going to be moving this along. We had some issues with Mass Highway. They didn't want to let this thing come across the Massachusetts border. And the driver, there was a lot of communication between myself, Rose Forbes, and Dan Webb, who put up the one in the tech park, because you have to communicate about this stuff. We're on a learning curve. And so, you know, I called up Ian Bowles and said, hey, we need some help with Mass Highway. Maybe they haven't heard about the state's wind goal. And we suddenly, okay, you're good. So we, you know, stranded on the Massachusetts border for a holiday weekend. It's not really fun, because then you try to get everything coordinated. You've got your crane for $6,000 a day. You know, you've got all of your crew, and ching, all that stuff is adding up. And you want to get the thing online as soon as possible, right? It's a $5 million investment or thereabout. You want to make sure that everything goes smoothly, that the equipment arrives safely on site.
When the crane is here, can it go on that pad, or?
Nope, it's on a big track, you know, just like a bulldozer kind of thing.
So it doesn't need to be on it.
No, in fact, we had a smaller crane that they used to move the blades off of the trucks and things like that, and that crane was the assist crane putting the big crane together. And so then it just scoots over there, and I've never met the cooler guy in terms of the operator. You know, they move this thing so slightly. You cannot be a I'm going to light my hair on fire kind of person. Because, I mean, the other thing is you put up a wind turbine where there's wind. And so it's kind of crazy that the wind can pick up really fast and suddenly you're in the middle of a blade lift. You've got to be really cool in terms of being able to operate and steady everything. So it went up really fast. We had some issues in terms of commissioning this machine with our witness test with the utility. You have to do a test with an engineer, and we had to put in this relay because of the fact that this is a Danish machine, and in Massachusetts they don't recognize the International Code for Electrical Standards. They made us put in this redundant piece of equipment. And so Vestas, of course, was pulling their hair out in terms of trying to make sure that it interfaced with their equipment. And so we came online at the end of March. So.
I missed what you said about ownership.
This is owned by the municipality of Falmouth. So the town did a bond. We went underneath Proposition 2.5. This was, again, one of those things that we went before the town meeting for vote in terms of ownership. We proposed that we had two options. We could do a third-party ownership and execute a power purchase agreement, but it didn't really make enough sense. The benefits were greater given the financial mechanisms that were in place at the time that we did the financing. It made sense for us to own and operate it.
And the drawback of you being the owner is you have more responsibility?
We do. We have to, we have an operations and maintenance contract. We had to train folks within the guy who's the operator up here. He has the alarm, so if this thing goes off, he's got the SCADA system, he can come in. So there's some training pieces that needed to take place. Let's see, our IT guy was very much involved in this in terms of, we have an online system that I can send you, Bill, if you want to share with everybody. You can see what the production is on a daily basis of this turbine. So that has to interface. Our town accountant had to be totally brought up the learning curve. We had to create a new account for this. And there's the renewable energy credits, then there's the net metering credits. So, there was a lot to be foisted upon her. And she's been really good. But we've had some time to get that all together. So,
could you run through the same questions Bill asked at the previous location? Permitting process, and then impact on the butters, noise,
yep. Sure.
Aesthetic,
yep.
Complaints, any of that stuff.
We have not had any aesthetic complaints to this project. There have been some sound complaints, and they're primarily over off of Blacksmith Shop Road was the road that we came in, and they're primarily over there. So the wind comes out of the southwest up here most of the time. So the turbine is now facing pretty much north, so envision it turning around, facing this way. So you got some prop wash noise off in that direction. And so we're right now in the process of doing some acoustical analysis around the neighborhood, and we'll be getting the results of that, I think, towards the end of this month. Vestas has turned this set it so that the machine gets turned off at 11 meters per second to see if that is helping reduce some of the noise. We've had some people complaining. They say that it sounds like a jet engine and it sounds like a boot in the dryer. I've come up here, a boot. I've come up here under a variety of wind conditions. I have not heard that. When the turbine yaws, you get a thump, and then it goes, you know, it's just like an instantaneous noise, and then there's no other, you hear the shoo, shoo, shoo of the blades. So I don't know. I haven't camped out in anybody's yard, so I can't speak to what the sounds are that they're hearing.
Roughly how far away are they?
I have a map that shows circles. It's like within a quarter of a mile. It's within that quarter of a mile, just on the edge of a quarter of a mile to a half a mile. So it's, you know, we'll see how it plays out. We need to follow up, and we're not experts on this, so we're looking to third-party people to do the verification of the sound, and then work with Vestas to figure out, is this a normal noise?
You mentioned the prop wash. Is it at a right angle to where it's facing, where you would get the most?
You know, I don't know, and that's part of what Vestas is trying to figure out, is look at the SCADA system so that they can look at the data and see, okay, we've asked some of the neighbors to log when they're hearing this, so that, I mean, we need cooperation or else we can't determine what the sound is.
No, I'm just wondering if the noise projects more that way as opposed to this way when it's, you know.
Oh yeah, just because if the whole rotor turns around and then you've got the wind coming across the blades, it's just, that's where the sound is going to fall away off there. So, okay, permitting. We had a bunch of permitting that had to be done. We did FAA, filed that 3 different times, and on Christmas Eve 2 years ago, we got a determination of presumed hazard after we had put a shovel in the ground. Oh. So there was some serious hustling around Christmas. Had to contact Congressman Delahunt and get up with the FAA. It had to do with the base. The Coast Guard had recently taken over control of the airfield there, and when we had done our filings, it was through the Air Force. This turbine and the Webb turbine happened to be in the glide path of a runway that's used around 22% of the time, but it's used for instrumented and uninstrumented approach. So we had to renegotiate the step down so that if it were really hazy or something like that, that they wouldn't know to come in super low. They'd have to keep up till they get past our turbines and then drop down. Critical.
It didn't require you to put a smaller tower in?
No. No. It wasn't on the table.
Is there a light on the tower?
There certainly is. Yep.
Not on the blade.
No. No, on the tower. I mean, it's marked in their flight. Anybody that flies around here, it's in the manual that this turbine is here, that the one up there at the base is here, and then the notice turbine is here.
Has anybody got the light?
Nope. Nope. So, let's see, permitting, we had to do natural heritage, we had to do mass historical, we had to do something else. That was we did a desktop analysis. I mean, and there are tons of shorebirds that come in here and feed in the settling ponds, and it was not an issue. Our company that did the feasibility analysis, they said there was nothing. We had to do some bales of hay around here during construction for the turtle.
Did the Wampanoag Indians weigh in?
They did not.
Okay.
No. Let's see. What else did we do for permitting? I don't know what else. We had to do an interconnection process with the utility. That's a pretty onerous process.
What about the harmonic noise we were talking about with the other machine? Have you had any issues?
We have not had any issues.
Before you leave the permitting, and as you point out, with the town, you need town meeting approval.
Yes. Yep. 7 times we went before town meeting. So, and I should also add, we did do paved pause and mass aeronautical. Those were the other. They wanted to weigh in on the fact that
you know what paved pause is?
No.
That's a great big radar facility.
Yes, over the horizon radar.
Yeah.
So.
Did NSTAR have to add capacity to accept what you were giving them?
No, they, we had to do a whole analysis of the infrastructure up to the point of interconnection. We have a transformer over here they really just wanted the relay. It was not really an issue for us. Yep. New meter. We're hoping it's a bi-directional meter. So, any other questions?
And Megan,
Yeah.
does the utility bring their wires to you, or are you responsible for bringing them
We
to
were
them?
responsible. Part of the contract here was to bring the power from the turbine over to the meter. And we had to do some, we combined some meters so that we're behind one meter now.
Is the transformer step up or step down?
Goes down to, I think it steps it down.
What is the voltage that you're generating?
That's a good question. I can't answer that. I'm sure you could find that information on the Vestas website.
I'm just curious.
So what percentage of the output is used by the waste?
It's about 25 to 30%.
And when you put the next one in, what will you do with that electricity?
All of that will go toward the aggregate municipal electric load. So this machine, I mean, we use about 11, almost let's say 12 million kilowatt hours a year. And the load in Falmouth for the town is only like 3% of the entire load used by everybody in Falmouth. So it's really scary when you start to realize that we use a boatload of power here. And ironically, I don't know how many of you guys are from townships, but you can't really manage what you don't measure, right? Towns are just now starting to wrap their heads around how much energy are they using. And what does that mean? People weren't paying attention to this until it suddenly meant, wow, our budgets are totally out of whack. And so for us in Falmouth, that was a really key point, is that we identified that, holy moly, this thing, I mean, our decision makers were not even able to answer those questions, like how much electricity is being used? How much do we pay in electricity every year? People were like, we don't know. So now we know how much electricity in terms of kilowatt hours. We can point to, yep, the fact is that the money really doesn't matter because it's the units of energy, the price changes. And typically on the upside of things, people are realizing that our electricity prices are going up. The load comes on primarily, about 10% of Falmouth is on the local sewer system, and it pumps up from Woods Hole. It's an engineer's dream, right?
Do they pay you the same amount of the electricity as you pay them?
There is one, if you look on the DPU's website, there is the tariff. You can look and see what it is, but there's a little chunk that is taken out, but as a municipality, we get the best deal that there is. So it's almost dollar for dollar. And that's another interesting point. So we had two different meters up here, and we had, when we went through our interconnection process, we had to pick which one was it going to be, because that rate schedule is going to be what we are going to get compensated at. So you couldn't just pick like, oh, we have a better rate over at the at the town hall than we have at the wastewater treatment facility. We'd like to have our credit based on that. You can't do that. There are rules about this. So
I'd interrupted Chris's question
Sure.
about the harmonic.
yeah, so we haven't had any issues with that. These guys make different size towers, and there are far more of these things out in the field than there are of the one that we just went to see. So I think they probably worked through that a little faster than the smaller company like Northern.
And then did you say that you got a governor on it basically now because of the sound issues?
Yep, well, just to figure out what it is, what's the sound. Is it happening at low wind speed? Right, so you have to figure this stuff out. So that's part of the Vestas protocol for determining what's going on.
But it's capped now at 11?
11 meters per second, it cuts off, shuts down.
And what's required usually for the startup?
I think it's about 3 meters per second, 3 to 4 meters per second.
We'd like it to start moving.
I know, come on!
We're on the bus on the way out.
Yep. Yeah. You can see it, we'll probably on the way back, right? So, any other questions?
Yeah, just wondering, the materials, are the blades made of some sort of...
They are made of fiberglass. I went to the manufacturing facility in Denmark, and they're pretty, and these guys actually bought up NEG Micron because they like their blade technology. And this is really, the V82 has been the workhorse of the Vestas fleet. I think there's balsa wood in the spars. And there's a cable in each. It's too bad we weren't able to go. You know, a few days earlier, the blades were on the ground over at the other turbine over there, and for you to see the scale, because you cannot get a sense of how large they are. I'm 6 feet tall, and the opening is, you know, I can't even reach the top of it when it's sitting on the ground. So,
you know how tall the letters are up there, Donna?
They're over 3 feet tall. Oh my.
Wow. When they were delivering the blades in Vinylhaven last summer, the truck that was delivering them went off the side of the road.
Oh no!
And get stuck in a ditch with all that equipment on it.
Yeah, they it's pretty impressive. They come in on these with these big trucks that have articulating axles, so they can get around the corners and things like that. But the super load was really, you know, the base of the tower. That was the really big issue for transportation.
So, Megan, we talked about sound issues with the neighbors. Has there been any flicker problems?
No, we haven't had any flicker. It's just been this sound.
Flicker is usually more of an issue in the wintertime, but you're a long ways away from it.
Yep.
So, about how many people have complained and about what?
11.
How many people are in that similar region?
Not about.
That's a good question. I usually send out over 100 letters. So, and our town engineer, I worked with him to figure out what was the best. How wide do we cast the net? We went for 950 feet past, off the lot line. So we have people that are getting our information that are on the other side of the 28. And my understanding from the assessor's office is that's pretty much the ceiling where they see people doing outreach. Like 1,000 feet through, it's pretty far.
From the property line?
Yes. And this is a 315-acre parcel of property.
And how far is this from the nearest property line?
We're 1,350 feet to that house where we saw coming in. I'm not sure how close some of the other ones are, but it's pretty far.
Is 1,350 the closest?
I'm not sure. I can't speak to that.
How and when did the town acquire 300 acres for town property, and did they have things like this in mind?
No, definitely not.
We're impressed.
That's a good question. I don't know how long this has been municipally owned. If we walk over here just a little bit, it's a fabulous view. I was like, we need to put a picnic table up here because it's beautiful. And when the wind's blowing the wrong way, it stinks up here, but such is the nature of the beast.
What is the size of the one we can see? The distance?
That's a Furlander 1.5. It's also on an 80-meter tower, so it's a 70-meter rotor diameter. So this is 82 meters. Pretty much an imperceptible difference.
Yeah.
But that's the one that's been having some issues where it's been shutting off at 50 miles an hour. But they will hopefully get that rectified soon.
Is this direct drive?
No, this is not. All three of these machines are gearbox technology. So that Northwind machine that we just saw, that is one of the few ones that are on the American market that are direct drive.
Is Vestas going in that direction?
That's a good question. I'm not really sure. I know that GE is going in that direction. Northern Power, that made the Northwind 100, they're actually going for a larger machine, a utility scale to compete with these guys. There's a German company that will not sell into the United States that makes an amazing direct drive machine.
Why won't they sell?
My understanding is that it's politics.
No, not that.
Yeah. So, any other questions?
So I suppose it's too early. Say if somebody complains, this is a thought that's going to come up. This is to increase the value of my property. Tax.
Richard, could you repeat that? We couldn't hear it.
Tax abatement for devaluing my property.
Somewhere down the line, is it going to come to a point where somebody's going to say my property's not worth as much as it was before this came into my neighborhood? So
Okay, so this is a really interesting question. I'm glad you brought it up.
I think this is what's all about in Vinyard, quite frankly.
So the reason I made a very clear point about this being an industrially zoned piece of property that's adjacent to a tech park, and on the other side of it is a gravel pit. Miles of gravel pit on both sides. Our dump is over there. When this property, you know, people bought this property knowing that it was adjacent to the wastewater treatment facility and industrial. It's all been industrially zoned for many years. So the property, according to our assessor, was somewhat depressed when people were purchasing it. So it's not like we suddenly decided that this was going to be industrially zoned. It's always been industrially zoned.
This is really an ideal site.
It is, absolutely. We chose it for that because we figured we don't have another site as a municipality that's this big with the wind resource. And honestly, we went into this just as an exploratory exercise. Let's see. Can we do it? Should we do it? We asked 7 different times.
It still took you 8 years, 9 years to do it.
Are you looking beyond 2 towers?
No. We're not.
Because
we wouldn't have done the second one if we didn't have ERA funding. I think we're really focusing on, you know, part of my job is to talk about efficiency first. And so, you know, every once in a while people will say, okay, so when you did your second inventory of the municipal energy consumption, what'd you find? Well, we found that we were going in the wrong direction. And that's really important, because we don't want to continue using more electricity and just generate it from a renewable resource. We want to reduce that load through conservation and efficiency, and that's really important. But part of the problem is the incentive money was available for this and for photovoltaics before the efficiency dollars were available. So what are we going to do? Pass it up? Absolutely not. So our focus is shifting to really cover the efficiency and the conservation. We've got a town hall that has no insulation in the ceiling. You know, it's kind of crazy. So we're focusing on getting those kinds of things rectified.
We should proceed.
Yes, we shall.
Hopefully find a power that's
My name is Paul O'Keefe. I'm the Director of Facilities. I've been involved with this project since day one. We put this out to bid back in probably the winter of 2005. This is a state-owned wind turbine, so it's administered by Capital Asset Management. We didn't get a contract signed until probably June of 2005. And of course, we immediately, one of the things you have to do is apply for an interconnection agreement with the utilities. That takes 6 to 8 months, or it did for us anyway. So, and going through the permitting process, we started in the summer of 2005. Fortunately or unfortunately, it depends on how you look at it, who you are. Being the state, we were not subject to local bylaws. The only thing we had to do was go through the Conservation Commission. And that was a process that started in September of 2005 and went on for 4 or 5 months. The immediate concerns that were brought up were property values, noise, flicker. The major one was the effect on birds, and the effect specifically on the endangered roseate tern, which nests down on Bird Island. As part of the initial study, they do ESS group with the environmental engineers. They do a desktop study, try to gather all whatever published data has happened over the last 20 years or whatever they can find, and nobody has seen a roseate tern since 1992. Well, anyways, so we went ahead. We agreed to do a post-construction study. We moved forward. We said after the turbine was built, if we had any issues, we'd do a study. If we had any issues, we'd shut the turbine down between the months of April and November. We were so sure we weren't going to have a problem, which we didn't. The study concluded that it's from 2.15 to 4 birds could be killed a year. We had, I think, one in each of 2 years. There was a seagull and an immature heron. So we put the terns are actually, it turned out there were actually quite a lot of terns here. So the 1992 information that said there aren't any around was obviously wrong. But the terns were actually quite smart. They, as soon as the turbine started, they're dead avoided. We actually started construction in March, just about March 15th of 2006. So it took us a little less than a year to go from signing the contract to actually starting the foundation. The foundation took a month to install. The turbine was ready for action April 16th. Okay, it took 2 days to install. We were ready to go April 16th. Of course, we hadn't had, one of the requirements of our interconnection agreement was we had to put a recloser out on the street to protect the utility. This is at the time of, this is just the aftermath of Hurricane Katrina. All electrical equipment, a lot of assets were down south. So this piece of equipment we needed didn't arrive until the end of May, early June of 2006. And we were ready to go. We actually got into, we were ready to spin June 16th. We did our test with the utility. We were ready to go. Of course, now we had to shut it down immediately because we were in the middle of this bird study process. We finally convinced Mass Fish and Wildlife to observe the birds interact with the turbine for several weeks. We said, okay, enough is enough. Let's turn it around and see what they do. So finally, over a progressive operation of the turbine, 3 days a week, 5 days a week, until October 1st of 2006, we actually went into production. We turned it on and we left it on. So it's been just about 4 years of operation. We generate about 1,000 megawatts a year. What does that mean to us? That's if we use an avoided electricity cost of say 15 cents a kilowatt, that's 150,000. Depends on your obviously your utility costs. We also sell renewable energy certificates, which unless you're in a long-term rec deal, depending on how you finance the turbine, it's a variable. I know that the town of Falmouth has a fixed rate for theirs that they negotiated with CVAC or Cape Light Compact. In the first year when we sold our RECs, we got $58 a megawatt. Next year was 55, 19. Our last sale was 17. So if you can get a nice long-term agreement at a high price, that's what you want to do. And the more renewable energy that comes on the market, the lower you're going to have that downward pressure on the rec prices. This turbine. This is a 660 kilowatt Vestas V47. The Vestas turbine is the 47, the V whatever still to the diameter of the normal meter. Okay, it's on a 50 meter tower. There's a 225 meter section. Okay, 164 feet to the nacelle. 242 feet when the blade touches up above the bottom. The turbine we just left on 80 meters. So obviously the higher you go, the more wind you're going to get, the higher your capacity factor. We're operating about a 19% capacity factor. At 80 meters down at Falmouth, you might have 30.
Our model shows 24.
Right, 24. So it's so the higher you go, the higher the capacity factor you're going to have. That's simply, it's not quite a measurement of efficiency, but it's something like it. If you take all the the kilowatts you generated in the year and you divide it by the total potential you caught if you operated at 87, 60 hours a year times the design rating, that would give you the total maximum you could achieve. This turbine has been very reliable. We have a 98% availability. The only time this turbine's been shut down in the last year has been for maintenance, which is twice a year here. The first year, it's 4 years, 4 times a year, and then we go twice a year. We have a maintenance agreement with Buzzards. Okay? We have a 5-year agreement. It's $12,500 a year, much cheaper than you can get now. But of course, it depends on the size of the machine. We'll be negotiating for years 6 through 10. It's less than 5% of the production of the machine. You have a multi-million-dollar piece of your project that needs to be maintained by experts, and if you lose a gear or something like that, you don't want to be responsible for it. Frankly, I don't have. It's a hike going up there. I know what it is to do 50 meters, and 80 meters is going to be a lot worse to climb up inside those towers. So, the noise issues, we have not had any noise complaints from the neighborhood. Doesn't mean they exist, but we haven't had any complaints. Flicker, we do get some flicker on the local houses here. There haven't been any complaints with that. I mean, that just happens during the winter periods, late in the afternoon. We actually shut the turbine down for baseball games at 3 o'clock in the afternoon because the road is right on the dining room. So noise was not an issue. Flicker hasn't been, there haven't been any complaints, although we do know it exists. The rule of thumb, now you have local bylaws everywhere, maybe now. I'm not sure if everybody's got bylaws, but the rule of thumb at the time was if you keep the local residents at least 3 times the hub height away, you get to that point where you're out on the noise resume, on the sound curve, where you don't raise the ambient noise levels above 10 decibels, which is the local DEP regulation. We've had the ambient noise reading out on the street out there was about 42 decibels. We had a reading not too long ago with kind of a moderate wind speeds here. It was up there was 47 decibels. So that was only a 5 decibel rise. What else? This particular turbine here is behind our electric meter, although we do net meter. When we installed this turbine, net metering wasn't in place for anything over 60 kilowatts. So we sized it for the neighborhood, and also that we were exporting a lot of power at a wholesale rate. Now you can go up to, with the municipality, you can go up to 2 megawatts in the metering turbine. You don't even need a load. Just the power needed to power up the utility of the turbine. Enough that you can be able to net meter. Then you can spread the load out through all your municipal accounts. This turbine generates 690 volts, AC, 3-phase. We need 4,160, so we have a transformer right here. This green equipment here. One of these is a transformer, it steps the voltage up to what we need. Okay, and the other one is a switch. And we simply tied into an electric feeder that runs between our power plant and it goes to our gymnasium. We had enough spare capacity on that line, and we were able to just tie into that. Interconnection costs, when you get that interconnection agreement with the utilities, you're going to have to sign. When they do a study, you might have to put in power lines, or maybe you have everything available, so that's an unknown cost there. We received a $500,000 grant from the Mass Technology Collaborative, which is now the Clean Energy Center. So one of the stipulations with that is we report our production every month for 5 years. Okay? So we have a revenue grade meter that's on the side of the turbine. It's not on the transformer over here. It's not Vestas' metering. It's a separate revenue grade meter. This is actually tied into, we use a vendor called Fast Daniel that takes all the data, puts it up on a website that the public can see. Also, I use that information every month to, they report it to the Mass Technology Collaborative, but I take it and I report it to the ISO New England so we can generate, sell renewable energy credits. What else? Does anybody have any questions that need me going?
Does the Conservation Commission have any questions or modifications for you?
The only stipulations were on the bird study. We had a successful bird study. There were no, as far as the notice of intent or any restrictions, there weren't any. It's within 100. It's within the 100-foot buffer to the coastal dune.
How much did it totally cost, including all the rents, and how long did it take?
Yeah. Okay. This turbine was supposed to be $1.3 million. Okay, they always have these unforeseen things. It was the first one. Okay, so they didn't know that you had to have a data acquisition system installed. When you tie it into any electrical system, it's a good idea to test it. We tested the wiring going to the top. Oh, you have a weak day. Sure enough, 3 days later, we ended up putting it on. So at the end of the day, single breed, at the end of the day, it was $1.48 million. We got a $500,000 grant. Actually, this turbine was totally paid for through legislative earmarks and grants and that type of thing, which for us is a zero payback, but if you were going out to finance it, you'd be financed at $900,000. Okay. With the interest, between rec sales and avoiding electric costs and export, part of the export, it generates about $200,000 a year. Okay, so we're fortunate. We're talking about 5 years. This turbine was installed in cost only $200,000. Photovoltaic on the roof. We have one solar up on our roof over our home. Close to $10,000. Wind 2,200. Projects now, I don't know what maybe you say the Falmouth project was. It might be in the $3,000 to $4,000 range. Turbine availability, they're not so available anymore. The supply and demand, so the cost has gone up. You might have paybacks now in the range of 8 to 12 years, depending on the project. Yeah, this is fairly usual. And actually what you hear is there's a little imperfection on one blade when you get there. And one of the issues we're starting to have with one of them that Vestas has got to come back and take a look at is we're having the leading edge is a taped edge, and just on the very tip there's starting to be a little separation. And that will cause that problem. You have a wind measuring instrument up there, you have an anemometer, you have a wind direction vane. It's all automatic, controlled by computer. Okay? When we get somewhere in the neighborhood of about 8-mile-an-hour winds, and we have it in the run position, the processor will say, okay, well let's try to generate some power. There's a hydraulic system up there that yaws the machine. It turns it into the wind, but it also pitches the blades. Okay, so when it starts up, it pitches those blades to about 45 degrees, somewhere around there, so they're maximum starting torque. Okay, so it gets that blade rolling, that rotor rolling. Okay, this machine here is a constant speed machine versus Falmouth with the variable speed. Maybe they run between 12 and 19 RPM, something like that. This is a machine that wants to run at 28.5 revolutions. The bigger the rotors, the slower they turn. You'll see the small ones, like the one over the upper cape there, the little 10 kilowatt, usually turns quite fast. So once we get up to 28.5 revolutions per minute, and the computer says with the 5-degree blade pitch, we can maintain that 28.5 revolution. Okay, it puts it on the line. It closes the circuit breaker. Now it's starting to generate power to the campus. Whatever the campus isn't using, it goes backwards through the meter and it starts powering up the local houses. Now, as the wind speed gets up to about 33 miles an hour, we generate more wind. Until more power actually, until we get up to the 660 kilowatts, which is the rated output of the machine. from 33 mile an hour winds up to 55, that's more than we need. And there's actually a 10% swing there. It can go 650 plus 10%. The electronic controls allow that. There's resistors up there to bleed off energy. But anyways, up to that 50 miles an hour, it's starting to pitch the blades, dump energy, that type of thing. At 55, when it sees 55 mile an hour winds for 100 seconds, it shuts it down. It just pitches those blades back to zero. With a few revolutions, it'll just sit there and coast. Always the control system keeping it into the wind. That type of thing.
Does it have a brake as well?
It's aerodynamically brake. There is a disc brake that's only used in an overspeed condition or if you hit the emergency stop in the machine. Yeah, we have this power plant building and the wastewater treatment plant building here are in the fall. Okay, that's a risk we choose to take. There's no bylaw that controls us here as far as fall zone goes. So that's it's not a common occurrence for these things to fall. So that's the risk we take. What else we have? Oh, well, now the turbine, whenever you're over 200 feet or within a certain proximity to the airport, okay, you have to have an application with the FAA and probably the Mass Aeronautical Commission. And they came back and said, we're not a threat to air navigation as long as we have certain lighting on the turbine. Well, initially we had white strobe lights during the day and red strobe lights at night. Okay? That was the only complaint, because the white strobes would be on the water, would hit the water, and the folks across the way would get blasted with this white. I mean, it really did its job. I mean, if you're a pilot, you're going to see this. We tried for a couple of years to remediate that. You can't put baffles up there. They're too big. They were 6 feet in diameter. Finally, we got the FAA to finance a pilot project to put an OCAS, obstacle collision avoidance system radar, on here. It would look out 5 miles. If there's a plane coming in this direction, they'll turn the lights on. Okay. If it gets within a certain radius and it's still coming on our collision course, sends out radio signals. Well, it turns out something they thought was only going to be about $100,000 was about $500,000. So that idea became. But anyways, FAA started to get smarter and they started to look into lighting of wind turbines and wind farms, and they changed the rule. Okay, and we kind of leaned on a rule that says it addressed wind farms, and we use it for the single turbine. I think it's what's being used now. If the turbine is painted bright white or off-white color commonly found on wind turbines, you can eliminate the white daylight. Okay, so we petitioned the FAA to say, hey, let's put on one LED light. And they granted that because they were tired of it. And the neighbors loved it. And they said, what can we do? It's just an LED. It's not a strobe. It's just a soft. LED is more directed too. It goes on straight. It doesn't go to the ground.
And that's red. That's a red.
It's a red LED.
But it's steady or it's pulsating?
No, it's at night it flashes something like 40 times. But it's the difference between night and day. And the neighbors who had the complaints were totally happy.
How close are your nearest abutters?
522 feet, something give or take to the when I mentioned the 3 times having to be at least 3 times the hub height away to get out of that kind of that noise radius that's acceptable. That's 492 feet. If you could be 1,000 feet away, that'd be good.
What do you get for complaints from the people that live and work here?
No complaints from anybody that lives and works here. We have 1,100 students as well. And it's second nature to them.
Across the water?
None. No, the only issues across the water were the lighting issue I just talked about. And as soon as we remediated that, then
When we're finished, pretty much as noisy as it gets right now.
It'll get, as the wind, it'll get a little noise. I don't like to use noise, but anyway, you'll hear it a little more, you know, when the wind speed picks up. But then you get to a point, if you're standing in front of it, if you're on the other side of the road, you'll hear it more. If you're back here, you won't hear it so much. But then you get to a point where the ambient wind noise overtakes the sound of the...
Unless it's calm on the ground and windier up there, something.
Sure, I'm sure there's a different situation.
When we're finished the questions, by the way, I'm going to suggest, if we have the time, that we might walk to the end of the field there and just case off and sort of say, this is what we're going to hear at one time the height, double the height, or triple the height. Just get a sense of what we can hear.
Look what I missed. Does anybody want to take a look inside?